In this video, we will look into the detail of how spanning tree protocol works. As you know, the first step to build a spanning tree is to elect a root switch. The root switch is actually the root of the spanning tree. Let's analyze this network diagram. In this network, we will turn on Cisco skill switch 1, then Cisco skill switch 2. As soon as this link comes up, switch 1 will send its own PPDU to switch 2 and claim itself as a root bridge. At the same time, switch 2 also sends its own PPDU to switch 1 and claim itself as a root bridge. Now switch 2 will compare its bridge ID to the bridge ID sent by switch 1. First, it will compare the priority, and it found that the priorities are the same. So it moved on to compare the MAC address, and it found the MAC address sent by switch 1 has a C4 lower than CH, so it accepts switch 1 as a root bridge. Similarly, switch 1 also compare its bridge ID to the bridge ID sent by switch 2, and it found that it has the lower bridge ID, so it still claims itself as a root bridge. Now let's turn on Cisco skill switch 3. As soon as this link comes up, switch 2 sends its PPDU to switch 3, saying that the root bridge is switch 1, and here is its bridge ID, and the cost from itself to the root is 4. At the same time, switch 3 sends its own PPDU to switch 2 and claims itself as a root bridge. Now switch 2 compare its root bridge ID, which is the ID of Cisco skill switch 1, to the root bridge ID sent by switch 3, and it found that switch 3 has lower bridge ID, so it accepts switch 3 now as the new root bridge. Similarly, switch 3 compare its bridge ID to the root bridge ID sent by switch 2, and it found it has lower bridge ID, so it still claims itself as a root bridge. Now let's look at this link. As soon as it comes up, switch 1 sends its PPDU to switch 3, saying that it is a root bridge. At the same time, switch 3 sends its own PPDU to switch 1 and claims itself as a root bridge. Now switch 1 compare its bridge ID to the root bridge ID sent by switch 3, and it found that switch 3 has the lower bridge ID, so it accepts switch 3 as a new root bridge. Similarly, switch 3 compare its bridge ID to the root bridge ID sent by switch 1 and found that it has lower bridge ID, so it still claims itself as a root bridge. Now switch 3 is officially the root bridge of this network. Therefore, all of its active ports change to forwarding states. After the root bridge is elected, the next step for a non-root switch is to select its root port. Root port is the port that has the lowest path cost to the root switch. Please note that there is only one root port in each non-root switch. First of all, each non-root switch can figure out its port cost either based on its bandwidth or configured by a network engineer. In this case, all ports in switch 1 and switch 2 have the same port cost of 4 because they have 1 gigabit per second links. In this network, switch 2 continues to receive the PPDU from switch 3 via the port G01. It calculates the path cost by adding the root cost to its post cost. Therefore, the path cost from switch 2 via the port G01 is 4. Similarly, switch 1 continues to receive the PPDU from switch 3 via the port G02. It calculates the path cost by adding the root cost to its port cost. Therefore, the path cost from switch 2 via the port G02 is 4. Now, switch 1 sends its PPDU to switch 2 via the port G02 and informs switch 2 that the cost to the root switch via itself is 4. Switch 2 calculates the path cost via the port G02 by adding the root cost to its post cost. Therefore, the path cost from switch 2 via the port G02 is 8. Since the root path cost via the port G01 is 4 and via the port G02 is 8, so switch 2 selects the port G01 as a root port, and the status of the port G01 changes to forwarding state. At the same time, switch 2 sends its PPDU to switch 1 via the port G01 and informs switch 1 that the cost to the root switch via itself is 4. Using the same process, switch 1 calculates the root path cost via the port G01 is 8 and selects the port G02 as a root port. The status of the port G02 is now changed to forwarding state. The final step in building a spanning tree is to select designated ports. Designated ports are the ports that are in forwarding state and forward superior PPDUs. There can be more than one designated port on a switch. First of all the ports of the root switch are designated ports. Non-root switch evaluate if a PPDU is a superior PPDU by this order. The switch port that sends superior PPDU will become designated ports. So the most superior PPDU is the one that's sent by the root switch. If it's not sent by the root switch, then the PPDU that has lowest path cost to the root is a superior PPDU. If it has the same path cost, then the PPDU sent by the switch with lower bridge ID is a superior PPDU. If it's sent by the same switch, then the PPDU sent by a port with a lower port ID is a superior PPDU. Now let's look at switch 1. When it receives the PPDU from switch 2 via the port G01, it sees that switch 2 is not the root bridge, but switch 2 has the same root cost of 4. Therefore, it compares its bridge ID to switch 2 bridge ID and found that it has the lower bridge ID because C4 is lower than C8. So it concludes that it has superior PPDU. So it makes the port G01 becomes the designated port and change its state to forwarding state. With the same process, switch 2 knows that it has the inferior PPDU, so it makes the port G02 becomes non-designated port and change its state to blocking. When a spanning tree is completely built and stable, the root creates and sends hello PPDU via active interfaces with the root cost of 0. The non-root switches receive the hello on their root ports. The non-root switches update the hello PPDU to include their own bridge IDs as a sender bridge ID along with their cost to the root, then forward the hello out or designated port